Hello class, due to the technical difficulty, I'm re-recording the class lecture 2 from last week again, and because sometimes the processing time is a little bit longer, so I'm making it into multiple video segment, hopefully about 15 minutes each. In this lecture, we're going to talk about the overview of electrical distribution system that will talk about some keywords and the important element of the network. So I think, as you may be aware of, that I asked everyone in the class to send me an email to introduce yourself, and if possible stop by my office and tell me your name, your background, and your anticipated graduation, and what do you wish to learn from this course. And we will continue the introduction to distribution system from the first lecture that I briefly talked about. This is a very important critical path for online folks who are going to get either the certificate or advanced certificate or even the master's degree. In this course we have 4225, which was originally registered as dual number, so we have 4225/5250. Now this is completely replaced with 5250. As you can see from this picture, the complexity of the network actually come from all the way the feeder all the way to the distribution network. And what is shown in this picture is a zoom out from a substation. As you can see in the background, this is actually the transmission system, and each of the triangular represent the load, which in this case we only show the primary network, so it is actually the distribution transformer. This is a better picture shown from the last picture, because this is more simplified in a way that you can see the important part of the distribution network. And as I said before, the distribution transformer, as I pointed here, 18, 19, 20, etc., this is actually the distribution transformer, and the rest of this is a part of the secondary network, which we as a consumer connect to some of the distribution transformers. So for example, in the residential area, there are several customers associated with one distribution transformer, whereas like another case is otherwise. For example, like distribution transformer placed in at Michigan Tech building, we might have multiple distribution transformer associated with one building, and in that case that is multiple distribution transformer to one customer. So what is shown here is that there is a diamond shape indicating a metering point, and those are the terms that we use: remote terminal unit, and then they are pole mounted devices like feeder remote terminal unit, as shown here, and this is referred to mostly the overhead line. So this is a much more complex system that I envision that we might have something more in the future, with more deployment of advanced metering infrastructure, as shown in the different color of the diamond shape, and the possibility to connect the network to the neighborhood primary distribution network, which means that in case of any fault occurring around the system, the possibility of reconfiguring the network and minimize the power losses and customer interruption can be minimized in this case. And of course that this will require careful planning in terms of the cost, how much the utility will have to invest, and how much they will have to see the benefit of it based on the historical interruption in the past. And what I mean by historical interruption is that there are better interruptions. For example, thunderstorm hit one line out and there's an outage, and of course this event can be random, but I think that having a good sense of the number of customers connected under one subsystem, as well as the event occurring, the reliability can be tremendously improved with the time reductions, and as well as the number of customers associated under the feeders. So it's important, but of course it's cost benefit balance analysis, so this has to be very careful plan ahead of time. So again, this is a sub-transmission to distribution system. As you can see that from the bulk power system all the way to distribution substation, and then this is what we usually refer to a power transformer, and then each feeder will feed to multiple distribution transformer, as you can see here, distribution transformer, and then step down to the consumer level. So distribution transformer called distribution transformer, DT, and then this is the power transformer, as I mentioned earlier. Before that is MVA, stand for the megawatt, and then this is 1,000 times different, which is the kVA, kilo VA. Nothing fancy here. This is just a keyword from 1 to 6 that talk about the classification of bulk power system, substation to sub-transmission system to distribution substation, primary network feeder, distribution transformer, as well as the secondary and the service. So those are the definition. You can see that, and I mentioned before that why we have a feeder that looks like a radio, which looks like a spinning tree, is because we are actually distributed the power from the substation, from the distribution substation, all the way to the consumer, to us in this case. So this is an example of multiple voltage level from a secondary perspective to primary perspective, and then the transmission voltage perspective. So mainly in North America, how the way we classify the voltage level, the nominal voltage. So as you can tell that sometimes people make this a group of 69, even 115 as sub-transmission system. And you know, sometimes the sub-transmission system may be configured in the ring way. We call it loop, ring or loop, or some of the distribution might be also configured in that way, especially in the metropolitan area. But you know, mostly in the rural area, the distribution network usually is configured in a radio network under normal operating condition. So what we have shown earlier, that was a one-line representative of the distribution feeder, and then the real part of that distribution feeder is actually looks like three-phase. So you can see that there's a three-phase connected to that. That's what we refer it to as feeder, and then you have a distribution substation, and along each part of that spread out is called lateral, as I highlight here, that you could have multiple distribution transformer tap on the different lateral phase, and as a result of imbalance in distribution network. This is the part that to show you a more intuitive between lateral and then the secondary part of the network. So I write this as primary and then secondary, and then the dot here actually segregate the different part of the network. That we refer this as a distribution transformer, and this is a household that can be connected from one phase to three phase, as you can see here. So lateral one phase doesn't mean that it must be a one phase in the secondary part of it. It can be configured in three phase as well. So in this picture, this is a much more typical one phase lateral of a primary network, and this, as I said before, this is for a distribution transformer, one phase of it instead of multiple phase. And so as the other customer that connect under this distribution transformer could be 45 kVA. So because each of those is rated as 10 kVA for each of those, so it would make sense to buy a transformer of 45 kVA transformer rather than 500 kVA, because obviously for economic reason, this must be much more expensive than the 45. And you know, sometimes we don't really connect this distribution transformer when we build a more house in the area. We could do that, but a careful planning have to be planned out so that, you know, this distribution transformer doesn't get overloaded. So for example, if you're going to build another 2 residential area here under this distribution transformer, which might hit 50 kVA, presuming that each of them 2 additional household will have consumed 10 kVA, then this transformer could be either replaced with a new one, or probably utility had to buy an additional distribution transformer to connect to those two new households. This is a very interesting picture, one-line diagram. So again, this is only shown the one-line diagram with switch. The switch can be remote controllable and non-remote controllable. So as you can tell, that between switch that could be 1,000 of customer here, and what is seen in this picture is that you have feeder 1, feeder 2 under the same substation, feeder 3, feeder 4 under the another substation, and feeder 5, feeder 6 another substation. The issue here is that if there is a fault occurring at this point, then this segment must be isolated from from the network, and then this switch, the breaker here, feeder 1, have to close back so that they will serve 100 customer at this segment. However, this part of the network might be having problem, because if you isolate this and this is closed, you won't have energy feed from this feeder 1 to the rest of the network because it's still in the radio fashion. So the normally open switch light in this case can be closed from other feeders. For example, in this case, could be either feeder 3 or feeder 2. So that's the reason why when we do the online powerful analysis, it's very, very important to have a very accurate data set in place so that we can do the best decision based on the metering data from all mounted devices to estimate the power loss and the voltage profile, which we'll talk about modeling later on in the rest of the semester. So that's the key, and dispatcher will decide which one is the best option, and they will execute the switching plan. So I think that this will be a very interesting picture, because we talk about radio unbalance in the primary network, and then as you can tell here, this is a secondary network. So you could have a mesh connection in the secondary part of the distribution network. This doesn't occur very often. Particularly, this will be designed for the downtown area, like high-rise building, just to improve the reliability of the system, so that they don't have to totally rely upon the power energy from the primary network. So all loads are rated in kVA, kilowatt, in that transformer unit. Another interesting case is the high-rise building. So they would have a different power transformer between the buildings, so that you can see that the radio supplied by the two transformer connect to the different primary feeder can be possible as well. Instead of going through the geographical area, this is actually spanning vertically throughout a high-rise building. Some of the subject that I mentioned earlier, that we are facing a different transformation of the grid from unilateral flow of power to possibly bidirectional flow in the foreseeable future. And that means that that would happen is when we introduce distributed energy resource, including battery, including the generators, could happen between a primary network as well as the secondary network. So you could imagine that having a electric car could means that it could be a new load or storage when you want to pump it back to the inject the power from the battery back to the grid. So the consumer actually will have more option in the future that decided what is the best way to do in order to optimize their energy consumption, as well as if they want to seal the power back to the grid. The only barrier here is the policy by the government, that if you want to sell the power back to the grid, it may not be the same rate as how utilities sell you back. So this is the issue that we are facing today, because utility used to sort of monopolize the business, and because they have to deal with the reliability of the grid most of the time, and have to maintain the grid as well, so that they take full responsibility of that. But then now, because of the changes that we are facing this day, so it's really it's unclear still how this would be play fair, so that everyone could participate in the energy market. So this is still an emerging subject to talk about. I mean, the easy part is that you open the switch, the electrons just simply flow wherever they need to go based on the physics. But there's another policy aspect of this, which will have to be part of the consideration. This is the communication infrastructure that I mentioned on lecture 3 before. You have the distribution management system and corporate billing computer to deal with the energy bill for each customer, and the interaction between this operational center, and then as well as the customer billing center, how they coordinate about the energy consumption and all that. And of course, it's crucial for utility to make sure that the reliability of the system is maintained well, because high reliability means better sales to utility, and that's the job of utility, to make sure that how they can respond to the outage quickly, because it's all as a function of the time and the number of customers. If you have the grid has been experiencing the outage, time means money, the number of customer means money. So there's a different indexes out there to measure the reliability of the distribution system correspond to time and the number of customers.